Hi guys, just a quick one. Just taking delivery of the Loki board, the Loki V2, although there's still some problems I'd like to iron out in the next version. Everything is good on this board. All the holes are correct in the correct place and everything is of decent build quality considering what I paid for it. I'm just going to do a quick time lapse of me laying it up now. As you can see, I've just put the terminal blocks in first, but I might do all the small components like the resistor, the capacitor, the diode and the fuse first, and then build the larger components up after. But we'll see how this goes, and yeah, awesome. Hi guys, just gonna do a quick voiceover whilst this plays, otherwise it's gonna be dead. So yeah, when the soldering the board, the hardest part was definitely the larger components, where I used a bit of blue tack to hold them onto the other side as I soldered them. You may need an extra pair of hands when soldering some of the components if it's new to you, but stuff like resistors you could potentially solder on the wrong side of the board and they'd still work, but other stuff such as the Arduino you definitely have to put on the side where the silk screen is, so just be wary of that. So yeah, that's pretty much it. It was pretty easy. I've got the Loki board that's just been soldered together, hooked up. Currently I've got a supposedly 9-volt battery powering the board. Of course, you can power it from anywhere from 6 volts up to 36. As you can see, just got the voltage and the current sensors up at the moment. I haven't got the RPM and the temperature, but I know they both work because I've been testing them. But I was just calibrating the current sensor, and as you can see, the voltage sensor is definitely working because it's measuring the power supply, and currently it's at 8.1 volts. I checked it last time, it was about 8.2, but I can imagine it's gone down. But yeah, we've got the current sensor currently hooked up, and if you can imagine, this is because we've got 10 turns in the current sensor, gives you a multiplication factor of 10. So whatever's red here times by 10, so we've got 3.4 amps. Right, there we go. And currently we've got 3.42/5/8. You always want to read more than less. So there's still some calibrating to do, but clearly it's up to spec. If I reduce it a little bit to say 3, somewhere around 3, we are going to end up reading 30 amps, which is fantastic. So we're reading to pretty much within the amp on current, which is what you need. You're never going to get a great accuracy with a Hall effect, this kind of high power Hall effect sensor, because they can go all the way up to 150 amps. So yeah, great. We'll see what we can do with this in the future. I've gone and plugged absolutely everything in, so all the functionality is there, apart from the current sensor, because currently I'm using the power supply to power the board. So currently we've got 14.1 volts in, and as you can see we've got nearly 1 volts in, so it's just 0.01 out there. Got the temperature sensor hooked up, which is this waterproof DS18 something B20 or whatever it is. And we've also got amp hours. The reason that's not going up very much is because we're not actually using any current, so that's not going to go up really much at all. This has only been on for a few minutes. The main thing is the RPM sensor. So we know the current sensor works, and we're going to switch on this little motor that spins at about 2000 RPM. I've tested it with a tachometer externally. And we've got the infrared sensor here, which works in all light, and it's going to trip the sensor with 2 of these staves. It's calibrated to do that. So if I turn it on, it's going to make a horrible noise. I'll show you. Plugging it in would be a good start, wouldn't it? And it's going to make a horrible noise here. RPM 0. Slow there, so tripped it. 2200. If I put my arm in the way of it, it should go down. There it goes 0 there. Very nice. So that's it, just tripping the infrared line there and getting a pretty accurate tachometer reading. So just to show the data logging file that you get off the SD card in the module when you put it in. So it just sticks out there, or you can have it mounted off the board with some wires. Just press in, take the SD card out, slot it into your computer using an adapter, and it will give you a file called datalog. And then this is some data from earlier. This isn't data we just gathered, so the values may be slightly off. But what you've got is your voltage, your current. I believe that's your RPM, then you've got your temperature, and then you've got your milliseconds since the start of the program. And as you can see, this is me testing stuff out and doing lots and lots of different things with the board. So you see the values going all the way up and down, up and down, up and down, up and down, up and down. So yeah, I think that's me playing with the currents and such. Anyway, so that's how you get it. And what you do is you would save that, pop open Excel, import data, and then separate via comma, because you've got a comma in between each data point. So yeah, there you go.